Okay, here we are, quarter 4, week 4, day 1. We are solving a subtraction problem, and we are solving an addition problem, and we have decimals. So we have to line up the decimals. So we have 382.04, and we're going to line that up with 6.3. And we subtract. So we can put a 0 here if we want to. 4 minus nothing is 4. We can't take away 3 from 0, so we're going to have to borrow from the 2 and make it a 1. This becomes a 10. So 10 minus 3 is 7. Now we have 6. We have to take 6 away from 1, which does not work. So we make the 8 a 7. This becomes an 11. So 11 minus 6 is, 5. And then we have 7 minus nothing, which is 7. 3 minus nothing, which is 3. Bring down the decimal. 375.74 is the answer for the subtraction problem. All right, now we have the addition problem. We have 49.038 plus 4.97. Okay, this time we're adding. So 8 plus nothing is 8. 7 plus 3 is 10. Carry the 1. 9 plus 1 is 10. Carry the 1. 9 plus 1 is 10, plus 4 more is 14. Carry the 1. 4 plus 1 is 5. Put the decimal down there. It's 54.008. Fill in the blank. We have 4 meters is equal to how many kilometers? Okay, so I know that there's 1,000 meters for each 1 kilometer. But we want to get 4 meters. Okay, this is interesting. So we're going to go all the way down from 1,000 down to 4. So we have to see, if we're going to do that, we have to scale it down. So what you're going to do is you're going to take 1,000 and divide it by 4. And that shows that this relationship is 250. And what you're doing to get from 1,000 down to 4 is you're definitely not multiplying by 250. You are dividing by 250. So to get the same thing, or to keep the equivalent ratio, you have to divide by 250 up here. So if you do 1 divided by 250, that's going to be equal to 0.004. So there we go. Okay, the other thing you can remember is if you want to, if you're anytime you're dividing by a base 10 number, okay, like 10, 100, 1,000, 10,000. Okay, you just move the decimal over 3 places. So technically, we could have just done this and go 1, 2, 3, and made it 0.001 kilometers for every 1 meter. And then at that point, we just do 1 times 4, which is 4, and then 0.001 times 4, which would be 0.004. Okay, so we could have done it a couple different ways, but there you go. There's a couple options, and let's go to the next one. What is the value of 4? And then in parentheses, 3x plus 5 when x equals 11. Okay, so they could have just stuck it in there for us, but they're kind of getting us used to kind of some algebraic stuff by using variables. So we're just going to put the 11 in for the x right here. So we have 4 times, and then in parentheses, 3 times 11 plus 5. Okay, so then at this point, we got to make sure we have the in parentheses there. All right, there we go. And then at this point, we're going to have to do what's in parentheses first, right? So 3 times 11 is 33. So now we're left with 33 plus 5 inside the parentheses, and then times 4. We have a couple different options now. We can actually do 4 times 33 and 4 times 5 and add them together, or we can do what's in parentheses first. So let's just do that. So we have 33 plus 5, which is 38. So now we're left with 4 times 38. And then we have 38 times 4, and when we do that, we end up with 152. All right, so when we put in 11 for x, and then we solve, and by doing order of operations, we end up with 152. All right, find the volume. We know the volume is length times width times height. Okay, so basically we're trying to find out how many tiny little cubes will fit inside of these, each one of them 1 centimeter by 1 centimeter by 1 centimeter. Okay, so let's go ahead and do that. So we have 7 times 20 2/3 times 9 1/3. Okay, so we need to make all of these into, instead of mixed numbers, into improper fractions so we can solve it. So 7 is going to end up being 7 over 1. Okay, then 20 is going to be 20 times 3, which is 60, plus 2. So it's going to be 62 over 3. And then for 9, it's going to be 9 times 3, which is 27, plus 1 more, which is 28. So we have 28 over 3. So that's what we're going to multiply together. So we're going to have kind of a big number here. So we can see if we can do some cross-reducing, but we'll just wait on that. So we'll do the top numbers, the numerator, 7 times 62 times 28. And that's going to equal 12,152. All right, then let's do the bottom, the denominator. We have 1 times 3 times 3. Well, 3 times 3 is 9. Okay. So then we're going to take 12,152 and divide it by 9. And it goes into it 1,350 times, with just a little bit left over. So if we take 9 times 1,350, that gives us 12,150. So what's the difference between 12,150 and 12,152? Well, that would be 2. So that's what's left in the numerator, and the denominator is a 9. So there's our answer. It's kind of crazy, but it's 1,350 and 2/9. Oh, yeah, and it has to be centimeters when we're talking about volume cubed. Okay, so 1,350 and 2/9 centimeters cubed. Draw a line plot to correctly display the data. All right, I went ahead and drew it. How many 3s do we have to plot down there? Well, there's going to be 1, 2 3s, right? How many 5s? So we skip 4, go to 5. We have 1, 2, 3 5s. How many 7s? 1, 2 7s, right? There's 2 of those. There's 1 8. We'll plot that. There's no 9s, no 10s, no 11s, no 12s, no 13s, no 14s, and then there's 2 15s, which means if you remember from the previous videos, mean will not be our best measure of center because we have some data out here that's way out in the middle of nowhere, okay, and that will skew the average. So mean will not be this, but we're going to have to find it anyway. All right, so we have it plotted. Let's start finding the mean, median, mode, and range. Okay, so the one that's always easiest to find is the mode, okay, because all you have to do is look and see which one happens most often. And if we look at our little line plot down there, the one that has more x's above it is 5. So our mode is 5. Or we can look up here and see that there's 3 5s, and there's no other number that has that many. So the range is another easy one to find. You just see the highest number, which is 15, minus the lowest number, which is 3. So 15 minus 3 is 12, right? Just 15 minus 3. And then the median is the number in the middle, okay? So we're going to kind of see, there's 10 numbers in this data set, right? So if we count in 1, 2, 3, 4, 5, I think that should be right there in the middle. And there's 1, 2, 3, 4, 5, which means our middle is 5 and 7. It's a shared middle. So what you're going to do is you're going to find the average. So you're going to do 5 plus 7 divided by 2. Or what number is right between 5 and 7? Yes, the answer is 6. So the median is 6 for this data set. Now we need to find the mean. All right, so finding the mean, you have to add up all of these numbers And I did that, and it equals 73. And then we already know that there's 10 numbers in the data set, so it's 73 divided by 10, which means I know that all I have to do is move the decimal over one place to the left, and the mean is 7.3. Which is the best measure of center? Well, we already said because of these outliers here, that's not going to be mean. Okay, so at this point, we typically go with the median. So the best measure of center is the median. All right, that's all there is for that one. All right, use the box and whisker plot to answer the question below. The question is, what is the interquartile range? And you saw that I already have a bunch of stuff written. Okay, this here is the highest number in the data set. This here is the lowest number in the data set. Okay, so those are orange. This is the median right here, the middle number. So if you have the data set, you find the number in the middle. And then this here is the lower quartile. So that's the middle number of the bottom half of the data. So you slice all the data in half, look at the bottom half of the data, find the middle number. And then this one here, you slice the data in half, look at the top half of the data, and find that number in the middle, and that's your 21. So the interquartile range is basically the distance between the upper median or the upper quartile and the lower quartile. So all we're doing is 21 minus 15. Okay, so 21 minus 15, and that's going to give us an interquartile range of 6. So the IQR is 6. All right, so again, that's the difference between that spot and that spot. All right, there we go. Graph the ordered pair 0, 0 and its reflection over the y-axis. Okay, here's our y-axis. All right, so let's plot 0, 0. Well, we go over 0. We go up 0. And we are right here. So basically, we never leave the origin. We just stay right there. And then to reflect it across, okay, if this was, we can't go anywhere with it. We just basically, if that was a coin, to reflect it, you would just flip it over. So now this side of the coin is over here and vice versa. So really, it doesn't look any different. It's just the same thing. So if we're going to reflect it across, it really doesn't look any different. We kind of just flip it. So there it is. We've done it, and the reflection, they're both basically sitting right on top of each other. All right, let's move on to the next one. Place the following numbers on the number line below. Okay, we have negative 1.25. So we're going to go to negative 1 and then just a little bit further to the left, and we're just going to mark that one right there. Okay, and then we have 0.1. Wow, that's just slightly more than 0. So it's going to be just a tad to the right of the 0. So that would be that one. Okay, and then we have 2.9. Well, that's almost 3, right? So we're going to do 2.5, get to almost 3, because one more tenth would end up making us 3. And then negative 2.6. So again, we're going to go left of the 0, get to 2.5, and then just a little bit past that one is negative 2.6. If point A is located at negative 6, 3, so if this is the origin, we can go to the left about 6 and then up 3, and it would be about there on a coordinate plane. And point B is located at negative 6, 0. So again, we're starting at the origin, go negative 6, and we stay right here. Okay, what is the distance between the 2 points? So how far is it, basically, from this one to this one? Well, since the negative 6's lined us up, straight up and down, then all you have to do is find out what is the distance from 0 to 3, and that's just 3. Okay, so without even graphing it, you can kind of figure that out. All right, so here we go. We actually put it on the graph. So the key to this is as long as the x is both the same, like the first one, if they're both the same, then it's just the distance between these two. And it would also work that if this was the same number and this was the same number, then you would just find the distance between the other side. So You don't really have to graph it, and that's what it's trying to show you.